Hello, ladies and gentlemen. Okay, this is part 4, number system. Okay, and the next topic we're treating is binary system. So, like I said, I'm not here to bamboozle you with a lot of statements, start writing. No, I just try to go straight to the point so that you can get the understanding of what binary is all about. Okay, from the word by means what? Two. Okay, so the highest number you can get under binary is what? Is 1. Okay, from 0 to 1. Like I give an example in part 1. That table is very important. Okay, I mentioned 2. 2 is what? 0, 1. Okay, so if I mention 5, that is 0 to 4. But in this case, we're dealing with binary what? System. So I can give you numbers in base 10 and ask you to convert to what? To base 2, or convert it to binary number. So, or binary system. So bi is what? Is 2. So we have let's assume we have maybe, let's say 1. Let me start with 1. I can also have 0, but there's nothing we can do with 0. 0 is still 0. Okay, let's assume we have 1. Let me just go straight to the point. Let's assume we have let me divide this. Let's assume we have 1 in base 10. Okay, so that's example 1 now. That's example 1. Okay, let's assume we have 1 in base 10 and they ask you to convert it to binary, or they ask us to convert to what? To base 2. So to base 2, okay, so if they ask you to say convert to base 2, okay, don't let me just write base 2, let me say convert to base 2, convert to binary. Okay, so convert to base 2. Okay, so what do you do? So just have your table. Okay, you have your 1, you have your 2. Okay, so the question you need to ask yourself, can 2 go in 1? No, it's not possible. What do you write? You write what? 0. Okay, can 2 go in 1? No. What do you write? You write 0. Remainder what? 1. Okay, that R, the R here stand for what? Remainder. Remainder. That is what is remaining. So 2 cannot go in what? In 0, in 1. 2 cannot go in 1. Can 2 go in 1? No, it's not possible. You write 0. So the value that is remaining, which is R remainder what? 1. So it means just to tell you that base what? 1 base 10. When you convert to what? To base 2, you will still have 1. Okay, 1 in base 10. When you convert to what? To base 2, your answer will still be what? Be 1. So now to buttress further, let's take 2 now. Let's take 2. Okay, let's say example 2. 2 to base what? To in base 10. Okay, we want to convert to base 2. Convert to base 2. Okay, so what do? You have your table, you have your 2, you have your 2. So this is the 2 that we are the base we are converting to. This is the value here. So this value is the one that is here. Okay, so what do you ask yourself? 2 in 2. 2 can go. When I say 2 in 2, it means 2 divided by 2. Okay, 2 in 2, that is what? 1. Is it remaining anything? No, it's not. Remainder 0. It's not remaining anything. When you divide 2 divided by 2, 2 can go in 2. So you still have your 1. Okay, 2 divided by 2 is what? 1. Is it remaining anything? No. R means what? Remainder. So because it's not remaining anything, you have your remainder what? Remainder 0. Okay, so now what do? You move further again. You put your another 2 here. Okay, so what are you trying to do? You are trying to divide it until you cannot divide it no more, until the value cannot go no more. Now look at this. 2 in 1, it can't go. Okay, you cannot divide 2 in 1 because the number here is higher than the number here. The same thing applies when we did the one for base 1 base 10 to base 2. 2 here is higher than this, so you cannot divide it, so you just have to write 0. So now the same thing applies here. 2 in 1 is not possible. I write what? 0. So what is remaining is what? Is 1. So that is the base, that is the knowledge. So when you are counting your base 10, it means this your value, you count from what? From the bottom to the top. So it means therefore 2 base 10 is equal to what? 1 0 in what? In base 2. So that is it. It's as simple as that. Okay. 2 in base 10 is equals to 1 0. 1 0 in what? In base 2. So it's as simple as that. So if they ask you to convert from one basis, convert from base 10 to another base, this is exactly the method you will use. Okay. You will use this method so that you can get your value out. So even if at all you see it in your theoretical part, or perhaps in your classes, maybe your teacher gave it to you, so you should know what to do. So 2 base 10, you convert to base 2. All you just need to do, you have your table. This is the 2 that you're converting to. This is the 2 that is given to you in the question. Okay. 2 in 2 will give you what? 1. Is it remaining anything? No, it's remaining 0. It's not remaining anything. So 2 in 1, okay, because this is higher than this, okay, so you cannot divide it. So what you just need to do, this is higher than this, is what? Is 0. Then what is it remaining? Is remaining this 1. So since it's higher, so at the end of the day, you have your base. It's a logic. Just understand the logic. When you understand the logic, it becomes permanent. Okay? Put it in your subconscious brain for you to know that yes, anytime you are having your you are doing conversion from base 10 to other bases, okay, you do your table. So let's assume let's for number 3 now. Let's say example 3. So let's say base 3 in 10. You want to convert it to base 2. Okay. Don't forget, instead of me writing TEN, I can also write what? I can also write the figure, which is 1 0. So this one, if I want to convert this one to base 2, I have my 2 here, I have my 3 here. So this is a 3, okay, like I did here. This is the 1, okay. You have your 1 here so that you don't get it confused. So you are converting to base 2. 2 in 3. You see now, 3 is higher than 2. So I can find 2 in that 3 one time. So it means 2 in 3 is what? 1. Okay. It will remain what? 1. Do you see now? So when you take 2 from 3, what will it remain? It means 2 can go in 3 one time. Then it will remain 1 to make it 3. Don't forget. Okay. 3 minus 2 is what? 1. So it will remain 1. So at the same time, what do you do again? You do another one, which is that is 2 in 1. So now it means that 2 in 1, this is higher. You see that this is higher than this. Okay, this will be what? 0. It will remain what? 1. Do you see now? So it will remain 1. So at the end of the day, you see that this is becoming more interesting. 2 cannot go in 1. The value here is higher than this, like what we did here. Okay, so since it's higher, it will be 0, then the value will be what? 1. So what you will now do here is that you will now count from the bottom to the top. So it means that 3 base 10 is equals to 11 in base what? In base 2. Okay, and don't forget, I've said it, in binary, the value you'll be getting is 0 1. You won't get value more than 1 in base 2. Okay, like I said in the table of part 1, okay, for 2 is 0 1. You can't get more than that when you're converting to base 2. You can see that the first answer we got here is 1. Okay, 1 base 10 is equals to 1. The second answer we got here is what? 1 0. So you can't see 2. Okay, that the highest you can get is between 0 and 1. So at the end of the day, you can also try for 4. Try for 4 base 10. Okay, Okay, 4 base 10, you can try it. Then also try for what? 5 base 10. So in part 5, we'll buttress more on number system for binary system, okay, so that you can also get the understanding. Please subscribe to our YouTube channel, continue to like, continue to comment, continue to share, so that we can reach a lot of young minds having challenges with mathematics. Cheers.